Hello, my third graders. I'm happy to be back again, ready to work on lesson 5 in our Into Math workbook pages. You don't have the actual book at home, but you've got the pages. So you're going to need page 21 next, and we're going to do pages 21 to 24 with this lesson. So have those in front of you. Let's start with page 21. And this lesson is about representing multiplication with number lines. So a way to help us be able to count when we are multiplying by using a number line. So instead of doing this big array, right? Remember last time we did arrays. Now we're going to use a new strategy called a number line. So after this lesson, you will be able to use number lines to represent problems about equal groups and to write multiplication equations, which we've been doing right along, right? Writing those multiplication equations. So let's start getting those brains ready to think about different ways that we could represent multiplication. So in Spark Your Learning, 4 friends are building a scooter from wood. Each friend has a ruler that is 6 inches long. The friends use the rulers to measure the length of a wood board. So we can see here, right? Each friend has a ruler that's 6 inches long, and we can see the rulers placed along the board. Show 2 different ways to find the length of the wood board. Well, one way we could do it is to do the array, right? We know we have 4 friends. And each one has a ruler that is 6 inches long. Which would mean we would need 4 rows with 6 in each row, right? So we could definitely do our array, 4 rows and then 6 in each row. That's one way we could find out. What if I were to see how this picture, one thing I'm noticing is they took each ruler and they placed it next to each other. So what if we did that? What if we had this ruler had 6 inches, and then we've got another ruler that has 6 inches, and another ruler with 6 inches. I'm trying to make them as close to the same length as possible. And another ruler with 6 inches. Couldn't we lay them all out? And if I lay them all out, 2 rulers together would be 12 inches, right? Because 6 plus 6 equals 12. So that means these 2 rulers together would be 12 inches. And then all together we would have 12 plus 12, which would be 24 inches. And then over here, right, we would have 24 as well if we were to count, right? 4, 8, 12, 16, 20, 24. So there are 2 different ways that we could find the length of the wood board. There are lots of other ways too, right? We could, similar to what we did here, we maybe not draw a picture, but I know I've got 6 inches plus 6 inches plus 6 inches plus 6 inches, and I know that 6 plus 6 plus 6 plus 6 equals 24. And then all of these, if I look at all of these, I know that I could write 4 times 6 equals 24. Or, just like we did with our commutative property, I could do 6 times 4 equals 24. So I know we only needed 2 different ways, but look at all the different ways that we could show 24. So this tells me that the wood board is 24 inches long. I hope you got that after all of those different ways, right? All right, so we're going to focus on one way. And when I look at these, when we talked about what we were going to be doing today is using a number line. And when I look at all of these different ways that we could represent our 4 friends with 6-inch long rulers, this one to me looks the most like a number line. See how it looks like a line with numbers that represent each section on my line? Well, that's very similar to what we're going to be doing. So this is probably the best representation of what a number line would kind of look like. And we're going to show that next. So on 22, let's build some understanding. I gotta move so I have room to write because my elbow needs to stick out. So, Kia uses a yardstick to measure the length of a wood board for a ramp. Each yardstick is 3 feet long. What is the length of the wood board in feet? So, what information in the problem tells the number of groups? It says Kia uses a yardstick to measure the length of a wood board for a ramp. Each yardstick is 3 feet long. What is the length of the wood board in feet? Well, it doesn't really tell us how many yardsticks we're using, but if I look at the picture, what do I notice about the picture? What I notice about the picture is this yardstick is yellow, and then we have another yardstick that is blue. So that tells me that there are how many groups? There are 2 groups because there are 2 yardsticks. So I'm going to put 2 groups, and in parentheses I'm going to write yardsticks. What information tells the number in each group? Well, right here it tells us that each yardstick is 3 feet long. Each yardstick is 3 feet long, so that means the number in each group, 3 feet long. And that is each yardstick. Oops, I didn't really need an S there. Each yardstick. So, we have been given a number line. Now, what do you suppose each one of these tick marks represents? Maybe each one represents 1, like when we're counting 1, 2, 3. And we would always start with the number 0, right? This would represent 0. This would be no inches, right? And then we could go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So this number line goes up to the number 20. We start at 0. We always, always, always will start our number line at 0. The very end is 0. For this case. We may at some other points use a different number to start, but for right now we're going to start with 0. So we're going to draw jumps on the number line to represent this problem. Well, how many jumps do you think we need to do? Well, the number of jumps is how many groups we have. So we're going to need to have 2 jumps. Well, how far is each jump going to be? Each jump is going to be how many are in each group. So if I start at 0 and I need to go 3 feet for 1 jump, 1, 2, 3. There's my one jump. And then I need to do a second jump. So I need to go up 1, 2, 3 more for my second jump. So there's my one jump, my two jumps, and I noticed I went 3 each time. So what number do you count to find the length of the board? Well, we're going to count by 3s 2 times, right? Because 3 is the number in each group, and I need 2 of them. So what numbers do we say as we count? I'm going to say 3, right? As I count, I'm going to say 3, then I'm going to say 6. So what is the length of the wood board in feet? It is 6 feet long. So when I use my number line, I'm going to make sure I figure out how many groups, so right, how many times I'm going to jump, and what is the distance, what is the number in each group that I am going to jump by. So in this case, I need to do 2 jumps, and they need to be by 3. So I need to go 3, 6. So my answer is 6 feet. Number 2 on page 23. So Sean uses 3 pencils to measure the length of a bar he uses to make a scooter handle. Each pencil is 6 inches long. How many inches long is the bar? So luckily our number line is already numbered out for us, so we don't have to do the numbering like we did on our last number line. But I know I'm always going to start at 0, and I need to figure out how many jumps am I going to make. I hope you said or are thinking I'm going to make 3 jumps. How many are in each jump? I hope you're thinking or you said 6. So for every jump, I need to move 6 spots on my number line. So my first jump is going to go to the number 6. What number will my second jump go to? Well, let's see. We need to go up by 6. 1, 2, 3, 4, 5, 6. It would be the 12. Notice I'm not counting the number I land on when I count my step, where I'm going to go for my next jump. So here's my first jump. Here's my second jump. I need to do a third jump. So I'm not counting here. I come to my next number. 1, 2, 3, 4, 5, 6. Okay, I have to jump to the 18. That's my third jump. So what multiplication equation could we write to model this problem? Well, I know that I have 3 groups, and there are 6 in each group, and that equals 18. So how many inches long is this bar up here? How many inches long it would be? 18 inches. Okay, so let's check for some understanding using a number line. So Mai uses 5 crayons to measure the length of her skateboard. Each crayon is 10 centimeters long. So I know that 5 crayons is my group, and 10 is my number in the group. Sorry, that was my speaker turning off. What is the length of the skateboard in centimeters? Well, let's think about it. If I know I have 5 crayons in a group, I could multiply that by 10 centimeters, right? Each group has 10 in it. And if I count 10 5 times, 10, 20, 30, 40, 50, it would be 50 centimeters long. Remember, this one wants to know how many are in each group. There are 10 in each group. So I am going to have my factors, 5 multiplied by 10, and that's going to equal my product of 50. Isla practices skateboard tricks for 3 hours each day. Or each week, I apologize. 3 hours each week. How many hours does she practice in 5 weeks? So which one of these is my groups and which one of these is my number in each group? Well, this says 3 hours each week. How many does she practice in 5 weeks? This is my group. I know I need 5 of them. And this is how many are in each group. So I know I need to jump how many times? I need to jump 5 times. And each time I jump, I need to go 3 spaces, right? I need to go up 3. So if I start at my 0 and I'm going to go to my 3, there is 1 jump. Now I need to go 3. 1, 2, 3. My next jump will end at a 6. 1, 2, 3. My next jump will end at a 9. So that's my 3rd jump. 1, 2, 3. My next jump will end at a 12. That's my 4th jump. And I need to get to how many jumps? 5. 1, 2, 3. So I will jump to the 15. There's my 5th jump. So that tells me that my answer is 15. So what multiplication problem or what multiplication equation could I write? Well, I know I have 5 weeks and there are 3 hours in each week. So that equals 15 hours. So 15 hours total that Isla practices skateboard tricks. All right, so now we're on to the on your own part. So again, you can pause your video here and go and practice it on your own and then come back to the video to check your answers and make sure you're on track, or you can stay right with me. Whichever you feel the most comfortable doing, I am perfectly fine with. All right, so page 24 on your own. Model with mathematics. Tamara uses 8 sticks to measure the length of a car. Each stick is 2 feet long. What is the length of the car in feet? Write a multiplication equation to model the problem and then solve. Well, how many do I need? How many groups do I have? This one is my groups, right? I need 8 of them. How many are in each group? There are 2 in each group. Each stick is 2 feet long. So each one of these 8 sticks is 2 feet long. So if I count by 2s 8 times, 2, 4, 6, 8, 10, 12, 14, 16. So I would have 16 feet long is my car. So Raffi uses 6 crayons to measure the length of a belt. Each crayon is 4 inches long. So if he's using 6 crayons, and then I know that each crayon is 4 inches long, how many inches long is the belt? So this tells me that 6 is my number of groups, and 4 is how many are in each group. So I need to jump how many times? I hope you're thinking 6. I need to jump 6 times. And how many are in each jump? There are 4 in each jump. So my number line is already numbered for me, thank goodness. I don't have to do that part of it. So I start at my 0 and I'm going to jump 1 time, and that has 4 in it. And remember, I have to go up 6 times. So my second jump will be up to the number 8. My third jump will be up to the number 12. My fourth jump will be up to the number 16. My fifth jump will be up to the number 20. And my sixth jump, my last jump, goes to the number 24. So guess what? That would be my product. So what number or what multiplication equation will I write? I will write the 6 crayons times 4 inches, which is each crayon is 4 inches. Each one of those 6 is 4 inches, equals 24 inches. So it wanted to know how long, right? How many inches long? So our last problem, and this kind of ties in what we did on our last lesson, on lesson 4, with this lesson, lesson 5. Remember, on lesson 4, we were talking about the commutative property, where if I have 2 numbers, I can multiply them in either direction. I can put them in either order, and I'm going to get the same answer. So this question wants to know how, so explain how number lines showing 7 times 8 and 8 times 7 would be different and alike. Well, in 7 times 8, how many jumps would you make? You would have 7 jumps in 7 times 8, and each jump would go up by 8. In 8 times 7, you would have 8 jumps in 8 times 7, and each jump would go up by 7, right? So then, how are they going to be the same? Well, they're going to be the same because their product would be the same. Their product or answer would be the same. And actually what it would be is 56. Now I'm okay that if you're following along with me, you don't write all of that in, just so long as you understand that you're going to do a different number of jumps by a different number of each group, right? But you're going to get the same product because you have a 7 and an 8 as your two factors. As long as the two factors are the same, when you multiply, your product or your answer will be the same. It just, as long as they can be in a different order. So you can have your 7 first or your 8 first and your 8 second or your 7 second. But you're going to get the same product or the same answer. Okay, so that's our last math lesson for this week. Next week we'll go to lesson 6, and I will be giving you some review so that way we can check and make sure that we're ready to go to move on to module 2. But for right now, we're going to end on lesson 5, and I hope you all have a wonderful week, and I will be back again next week with some more math for you. All right, I'll see you soon.